Okay, guys. So I have a WASP meeting in about 4 minutes, but I figured I'd get one of these going for you guys for tonight. So give me a sec while I turn the screen around. Whoa, I don't know what's going to happen on the other screen, but that's okay. And alright, so here we go. Wolves are sometimes observed to have black coats and blue eyes. Assume that these traits are controlled by single locus genes on different chromosomes. Assume further that normal coat color N is dominant. Okay, so what I'm going to do is I'm going to go N is normal coat. Everybody see this? Making my key first to N, little n, which is black. Okay, so it's black. So remember, we are trying dihybrid crosses here. So in every dihybrid cross, you're going to have two sets of traits. Okay, and brown eyes, B, are dominant to blue eyes. So here's brown, dominant to blue. Okay, and in case you guys were like confused where I found that, that's normal coat color is dominant to black, and then we'll just do this. And then brown eyes are dominant to blue. Okay. All right. So I'm actually gonna go run and go to the WASP meeting, and I'll come back and I'll finish this. Alright guys, I'm back from that WASP meeting. I'm pretty tired right now, but that's okay. Alright, so suppose the alpha male, alpha female of the pack, these are dominant individuals who do most of the breeding, are black with blue eyes. Okay, here we go. Black with blue eyes. Let's start with that one. What is your genotype if you are black? Well, it must be, I'm not on the pen thing. Okay, here we go. If you have, once again, so the alpha male and alpha female of the pack, these are dominant individuals who do most of the breeding, are black with blue eyes. Okay, so that's one parent, black with blue eyes. So black is going to be two little n's, yeah? Blue eyes, two little b's. Does that make sense? Okay, we got that one done. And now a normal colored eyes, well, normal colored coat, I'm sorry, which is going to be, we don't know. And we know that's going to be either two big N's or a big N and a little n. We're not sure about that yet. And then brown eyes, which could be two big B's or a little b and a big B. But luckily, they told us the female, which is the second case, is also heterozygous for both traits, which means she must be this situation. All right, does that make sense, everybody? So we can also click and zoom in on this spot here. Okay, let me erase that. Okay, so how do we get the gametes for each one of these? The same way that I told you guys before, you foil them. So this one goes to there, that one goes to there, this one there, and this one there. And when you do all that, you get NB, 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 all lowercase, okay? And those are the gametes. And you have to do it for this one too. So we go there, over there, here, and here. And this is foil, right? In case you forget, this is foil. And here are the gametes. It's big N, big B, and then outside, big N, little b. Inside, little n, big B, last, little n, little b. All right, so those are our gametes. Okay, so now we have to make a chart. But look, do you guys notice that we have all of the same situation over here? Notice there's four of them? Well, we can just use one. You don't have to use all four because they're the same thing. And if we reduce the ratios gotten from the Punnett square, we'd end up with the same thing. So let's cross these guys out. And now I'm going to make my square. Here's my Punnett square. Put big N, big B. Here we go. There's one. Big N, little b. There's another. And here's my last one. Last two. Little n, big B, and little n, little b. On the side, I'm obviously going to put little n and little b. So I go ahead and put these things together. And cross in, cross in. If you make a mistake, let me know. And then these two. Bam. So what is the genotypic ratio was one of the questions. In case you forgot what the question was, we go back up to the top. What are the genotypes and phenotypes of the offspring? Well, the genotypes are going to be what's in these boxes. So let's go ahead and write that. So genotypes Let's do the ratio. It's easier, but this is not going to be very fruitful here. That's okay. Is there anything that's the same here? No, they're all different, right? Every single one of these is different. So the genotypic ratio is 1 to 1 to 1, right? There's one of these, one of these, one of these guys, one of these, right? But the phenotypic ratio, this might be a little bit different. All right, or any, let's see. All right, so what does this guy look like? Let's see. So he's got a big N and a big B. So he's going to be, we go back up to our chart here. It's going to be normal, and he's going to have brown. So normal, brown. Okay. This one is going to be normal, blue. This guy right here is not going to be normal. He's going to be black, and he has a big B, and he's going to be brown. Black and brown, yes, like gold toes, which I just learned actually recently. And this guy is going to be black and blue. So these are the possible genotypes are right here, or phenotypes are right here. And the phenotypic ratio actually be 1 to 1 to 1 to 1, because they're all the same, just like the genotypic ratio. And the potential genotypes, or phenotypes, are normal and brown. Whoa. And then we have normal and blue. And then we have black and brown. And then we have black and blue. I know that was a little bit complicated for you guys, but in case you get confused, you can always come back, follow how we did it. We wrote the key, we wrote the cross. Here's the key. We wrote the cross. Foiled or distribute, it's Mr. Compton. Gametes, right? It's just the steps. And here, used Punnett square. And then here, we answered the question, okay? All right, well, good luck everybody, and we're done.